Welcome back to the Savage Sullivan Math website. Today we're going to look at some special cases using elimination. If you looked at our previous videos, you heard that these two variables are not set up quite yet for elimination because the coefficients do not match. So first we need to multiply one of the equations, sometimes both, but in this case only one, to make sure that the coefficients match. I'm going to multiply the top equation by 4 so I can eliminate my x's. So 4 times 2x would be 8x. 4 times a negative y is negative 4y. And 4 times a negative 1 is negative 4. I like to rewrite my equations so they are right on top of each other and aligned. All right, if I'm eliminating my x's, it's 8 minus 8 to get 0. So I'm going to subtract. 8 minus 8 is 0. Move on to the y's. Negative 4y minus a negative. Remember, minus a negative is the same thing as plus. So negative 4y plus 4y, that's 0. And then here, negative 4 minus a negative, again, same thing as plus. Negative 4 plus 4 would also be 0. Oh no, we've eliminated all of our variables. The very first thing you need to do is double check. Did you do your arithmetic correctly? Yes, we did. So if you eliminate all of your variables and you get an answer that makes sense, does 0 equal 0? Or maybe you got something like, does 10 equal 10? If the answer makes sense, then you know you have infinitely many solutions. If you think back to graphing systems, this would mean that the lines would be right on top of each other, so they share every single solution possible.
So now let's look at a second example that's going to be a special case. So when we look at this one, I see a couple of different ways I could go about eliminating. I know that I could multiply this top equation by a number if I want to eliminate the x's. I could also multiply the top equation by a number if I want to eliminate the y's. But just because x comes before y, I'm gonna multiply to eliminate the x. So I'm gonna go up here and I'm gonna think about multiplying by a negative so that I could add. And I'm gonna multiply this by a negative 2. And the reason I'm going to do that is because then this will become a negative 6 and I can add to eliminate it here. So when I rewrite this system, I'm going to have negative 6x minus 2y equals a positive 10, not forgetting to multiply the negative 2 by the negative 5. And then I'm going to just recopy this one, again, just to keep them aligned. And already we should have an observation here. We're seeing some of these coefficients are the same but different signs. So let's see what happens when I add to eliminate. So here I'm going to go ahead and I'm going to add these two equations together. Negative 6x plus a positive 6x is going to eliminate those x's. But oh no, negative 2y plus a positive 2y is also going to eliminate the y's. So I'm left with a big old 0 on this side of my equation. Remember that the variables also eliminate. We're not having 0y or 0x, just 0. The other thing we have to remember is to add the other side of the equation. 10 plus 10 is 20. Something looks a little funny here because 0 is not the same thing as 20. So we know that that's not equal, which means this system has no solution. And if we think back to when we were solving systems by graphing, that would mean that these lines are parallel to each other, which means they have the same slope and different y-intercepts. If you found this video helpful, please like and subscribe.